All right, this is still page 11 of math analysis, and we are going to do some kind of weird problems now. So the planet Strango has a diameter, so it has a diameter of 4,250 strangs. So strangs are a unit of length, right, or of distance. So they're like feet maybe, or miles or kilometers, or like who knows what they are, but they're not measuring angles. Angles are measured in dangs. So angles are measured in dangs, and there are 450 dangs in a full revolution. So this is really important. I noticed a long time ago that problems are just like a little bit harder if everything rhymes. And so sometimes I like to make these rhyme because there's actually research that shows that like the harder you have to like the more things you have to deal with while you're learning something, the more you remember it, which is kind of interesting. And I don't think a lot of students agree until later in life when they realize that it actually probably is true. So let's see if we can do this. How many Earth degrees are in 50 dangs? Okay, Earth degrees, 50 dangs. So dangs are angles, so 50 dangs. So I'm just going to do like a proportional reasoning thing here, and I'm going to say that 50 dangs. So let's use like let's use like a lowercase a d for that. And then there's 50 out of 450 should be x degrees, I guess, out of 360 degrees. So can we reduce this? Maybe. So 1/9 of 360 is equal to x. So what's 360 divided by 9? 40. So I think x is 40 degrees. Okay, proportional reasoning. It's a great way to go. What is a right angle on Strango? Okay, so a right angle is 1/4 of a full revolution. Would they call it that? I don't know. But that's what we call it. So it's 1/4 of a full revolution. So I think that we should do 1/4 of a full revolution, which is 450, which doesn't really simplify nicely. So I'm just going to say it's actually 450 divided by 4. I don't know. Well, we could do like, what is it? 112.5. So I guess we could do that. That work? Yeah, 48 and then 2 is 50. Yeah. So so what is this though? This is in dangs, right? Because angles are measured in dangs. You got to like keep track of that. It's the hardest thing to do. The hardest part for sure. How many dangs are in 65 degrees? Proportional reasoning. Let's keep going with this. Okay, so 65 degrees out of 360 degrees should be equal to how many dangs? So let's say x dangs out of 450 dangs. So if this was a planet that we were interacting with a lot, it'd probably be worth our while to work out that there's, we have 360 degrees in one revolution. They have 450 dangs in one revolution. So we could come up with a conversion factor, right? So this is what? 4/5, right? So if we want to go from dangs to degrees, we should multiply by 4/5. So this is degree. There's 4 degrees for every 5 dangs, I guess is kind of how we're like looking at it. So this is to go from dangs to degrees. So this is if we were going to interact a lot. So to go from degrees to dangs, we should do 5/4, right? So this should feel familiar. Like this is the idea that we worked out with radians to degrees and degrees to radians, but now we're just using these made up angles. They're not real. So this would be from degrees to dangs. So let's keep doing, and then it's a problem that my handwriting is so bad because dangs. Can you imagine like two space, like NASA and then like whatever Strango has, trying to like work together, and like there's just some minor problem where somebody confuses degrees with dangs, and then suddenly you're just like way off course. So let's see if we can get this. So I don't really know. So x is, so really it's 450 over 3. So we can use this conversion. It's 5/4 and then times 65. And so that's in degrees. I don't know, 325/4. And this is in from degrees to dang. This is in dangs. Yeah. So 65 degrees. This was yeah. Okay. So this is dangs. 325 over 4 dangs, I believe, is the answer. 300 plus 25, 325 over 4. Pretty confident about that. So we're just using like a ton of proportional reasoning here, which is exactly what you end up doing whenever you have all these weird measurements. So a great circle. So a great circle is a real thing. So sometimes in the notes I like make things up. Like I made up the planet Strango. Strangs and dangs aren't really a thing. But like, why not be a thing? You know, a great circle is actually a thing. Like the equator is a great circle. The prime meridian is a great circle. It's a section of a sphere that contains a diameter of the sphere. So like the equator, right? Think of the Earth. The equator wraps around, it's like the belt around the middle of it. The prime meridian, same thing, but it goes vertically. So great circles are a real thing. If two towns on Strango are 93 strangs apart, so strangs are a measure of distance, so they are that far apart. Okay, so let's start drawing. So we have, this is our planet, I guess. And then we have two things, and they're 93 strings apart. So what I'm going to do is I'm actually going to try to go like horizontal here. Let's say there. And then we'll put another one. I don't really know what would be reasonable. So they're 93 strings apart. So that's actually an arc length. And then do we know the radius of this planet? We sort of do. We know the diameter is 4250. So the radius is 2125. So 2125. So let's say that this is R, and R is 2125. And then that's also in strings. This is strings, this is strings, which apparently you abbreviate as just an S. Okay, so they're 93 strings apart. How many dangs apart are they in latitude? Okay, so what can we do here? Well, we can do the same sort of thing that we've been doing. So I have an idea, actually. We could actually figure out the angle in radians if we wanted to, right? Because in radians, so let's see here, radians, we would have that theta is just S over R, which in this case would be 93 out of 2125. So that's in radians. Okay, but now I need to get it into dangs. So what do I know? Well, I know that if I do the number of radians that I have out of a full revolution, which is 2 pi, so I can do 93 out of 2125 out of 2 pi should be equal to the value that we're looking for. So let's call this phi, because we haven't used it in a while. Phi out of a full revolution. So what's a full revolution for them? 450 dangs. So 450. This is in dangs. So let's go to the calculator on this, because I do not want to do this by hand. Here we go. So I'm going to say parentheses 932125 out of 2 pi. So this is radians out of radians equals, I actually do this kind of thing a lot. So I'm just going to say it's x out of 450. And then like, I just kind of like solve through, like multiply by 450. And then I actually wanted an approximation. So I'll say this. So I'm going to get 3.134. So phi, I'm just writing it in the notes, is approximately 3.134 dangs. So that's how far apart they are in latitude. I don't know if they have a concept like degrees, minutes, seconds. You know, when you're inventing a planet, there's so many things to consider, and I didn't consider like, do they break it down farther for their latitudes? I don't really know. But anyway, I believe that this answer is correct. So it was incredibly useful to me that at like the last second after I drew the picture, I thought to myself, you know what? Let's just use radians, right? Because I have the radius, I have the arc length, I can geometrically determine that angle using radians. And once I know radians, I could convert that to any system, right? So I could have converted it to degrees if I wanted to. I would have just done like my initial setup, So it would have been the same initial setup over here, but then I would have just said equals, I don't know, like theta out of 360, and then I would have solved for that in degrees. But since we're on this weird planet where there's 450 dangs in a circle, I had to use phi or whatever out of 450 and solve it. So you do get the sense in doing this problem, I think. I mean, the idea is that it'd just be better if everybody used radians. Like if everyone had used radians, then everyone would show up and be using the same angle measures. They're consistent across planets. This is a weird answer. They're consistent across planets, right? So no conversions necessary. No conversions necessary. And so like really, I'm gonna try to spell necessary. Really, if the engineers from these two planets had gotten together, they'd probably have been using radians and they would have been really happy about it. But unfortunately, it was like a bunch of lay people, you know, like they weren't thinking about this. Units of measure, though, like the linear units, it's a mess everywhere, right? Like feet versus meters versus whatever's, so many options. But angles we should have handled a long time ago. Like that should not have been controversial. So anyway, I think we're done with these, and I will be back in the next video to do more. So see you there.